we should have just told her. Okay, so, all right, we're going to get started here. So, what? All right. We're looking at box plots. Okay, next slide here. So our essential question at the top of the page, how do you compare two sets of data displayed in box plots? So we've looked at box plots, we made them, but now we're comparing two sets of data in box plots, okay? So our objective, we've got some big words here. So this way you know where we're headed. Draw informal comparative inferences about two populations or two scenarios of data. So again, we're looking at the data, we're saying what does it tell us about comparing two sets of data. Okay, next slide. So looking at a box plot, and this is something we're familiar with from the last lesson, what are 5 key points or key values that we can see from a sample box plot? Mina?
10, 20.
Okay, so if we look at, we're looking at, what does this box plot tell us? What are 5 key points that we see, that we can tell from this example? Emily? What's one?
The least value.
Okay, the least value. Listen. Okay, so we're looking at, but what is the 5 key points that the box plot tells us? Not necessarily the number line, the box plot. All right, Precious? No? Jose?
Median.
The median. Okay, Chloe? Upper and lower quartiles. Mina? And the greatest value. All right, next slide. So we find the median, the least value point. Go ahead and pinpoint these on your paper too in your example. The least value point, the greatest value point, and then the lower and upper quartile. So we're going to talk a little bit more about those terms. All right, let's look at an example. Go ahead. All right, so we have a box plot here that is a point scored in a basketball game. All right, so on your paper, take about 20 seconds and find the least and greatest value of this sample box plot. The least and greatest value. And again, you're going to use the number line for this one, okay? Show me with your eyes looking this way if you've got those figured out. Okay. And who has the least value? Raise your hand, please. Majad?
15.
So 15 for the least value. Greatest value? Santana?
30.
30 points. Remember, we're always including our units. Let's just get in the habit of including units in this, okay?
Second least.
Okay, so B, find the median and describe what does it mean for the data. Find the median in this sample and describe what does it mean, what does it represent for this particular set of data. Ready? Who has it? Chloe?
The median is 21, and it represents that 21 is the middle value of all the points scored.
Okay, so the median is the dot in the middle of the box, all right? And it represents the middle of all of the values in this data set. So half of the values are less than the median, and half of the values are greater than the median. So now let's talk about the lower and upper quartiles, those edges of the box. Find each of those and describe what does it mean. What does it represent? What do those points represent? Patil? Okay, so lower quartile, 17.5. And upper quartile? Irene? 27 and a half. All right, we're looking at in between those hash marks there. So what does that tell us? What do those points tell us looking at this data? All right, Georgie's?
The medians will be in between those numbers.
The which?
The medians will be in between both numbers.
Okay, so the median's in between the upper and lower quartile. But remember, we're thinking quartile, so we are thinking in quarters. But also, so we know the median separates the bottom half from the top half. So this point, how is it related to the bottom half of points? We had this a little bit. Okay, this is the center point, or the median of the bottom half, is the lower quartile. It's like, it is the median of all the values in between the median and the lowest point. And then the upper quartile represents the middle point of all the values on the upper half, above the median. All right, so now we want to look at the interquartile range. And that's the difference between the lower and upper quartile. So it's almost like the regular range where we're subtracting greatest from least. But this time, tell everybody's here if that's the attendance, okay? But this time we're just looking at the difference between those two numbers. So we've got it set up here, Q3, which represents the upper quartile. What number did we say that was? Anybody? The upper quartile point? Okay, 27 and a half, that's Q3, minus Q1, so 17 and a half. And when we subtract, we get 10. So the interquartile range is 10. And we're going to say 10 points, okay? We always are including our units. 10 points. Questions on that? Okay. Fatil?
I don't get it. Like, so they give you data. How do you find the quartile?
Well, okay, so in a box plot, they're telling you those points here, okay? And you are looking at what does it tell us? Where's the spread? We can tell that there's the bulk, there's a bigger spread here because this portion is wider than this portion. But now let's compare some box plots and that'll help us understand what we can use this for, okay? Yes?
I didn't get letter C.
You didn't get letter C?
Yeah.
The upper and lower quartiles?
Yeah.
So we found those. These are the points. The lower quartile
Okay.
is at the
End of the
left
box.
side of the box.
Okay.
And the upper quartile is the right point in the box. All right, the upper quartile. So those are actually those points. And this is something that when we're analyzing the data, so the data is already given to us in this case.
But I kind of put it in make a box.
Right. So we know how to make a box plot, and we're going to practice that some more too. But now we're looking at a box plot that is created, and we are inferring. We are seeing what does that data tell us. Okay, and again, we're going to start comparing two different ones so that we can, again, analyze the data. All right, so we found those. Majad, you got that okay?
Yeah.
Okay. All right, so let's look at, actually turn the page. Go ahead. Why is one half of the box wider than the other half of the box? And this comes from creating the box plots. We know, go back one, up. Okay, we know that this is wider because the data is more spread out. Okay? So there's a greater spread in the data. These are bunched together. They're clustered together. See, remember clusters, when you're looking at data, where data is clustered tells you a lot about the data that you're seeing. All right, go ahead. Next one. Okay, so now let's go to example 1 where we're comparing the data. Now this is two box plots with similar variability. So that tells us that there is the variability, which is the spread, is similar. But let's look at, we're looking at the same three questions. The shape, the center, and the spread. So we have two groups going shopping. Okay? And we have group A and group B, and their shopping in time is logged in minutes. Doesn't seem fair to only go shopping for minutes. It needs to be hours, but for this example, we're going to shop in minutes. So let's look at, compare the shapes of the box plots. All right, now when we say compare the shapes, we are looking at where is the data located and in comparison to each other. So who can just visually glance at this and tell me where is the data located, or how are they different, or how are they similar? All right, Georgie's?
Oh, the difference is one is wider than the other.
Okay, one is wider than the other. Is it greatly wider than the other, Sebastian? The medians are a little different, yes. That's a good thing to look at. Mina, what would you say? No? All right, Majad?
The quartiles are different.
Well, the quartiles are different, but are they greatly different? I mean, at this point, we're
No.
comparing. Okay,
It's
they're
only a half
a little bit different, but they're similar. Okay, they're not the same, but we can say they are similar. And part of this might be even just jotting down next to the example. You know, if this is 30 here, this is 31 maybe. That's pretty close. All right, and here we've got about 55 and 58 or 59 for the upper quartile. So when we look at this, we can say they are similar. The B says compare the centers of the box plots. Now actually this is where there's the biggest difference in these two. We have, when we look at the middle or the center, what term are we looking at?
I have a question.
Okay, question?
Okay, on number C, on group B, it says about 59 minus 32 equals 27, when it's not, it's 26, which is not, it's 27.
So now are you on this example?
No.
Oh, okay, yeah, let's stick with this example, okay? Yeah, we'll get to that. All right, so the center, what term do we use for the center, Jose?
Median.
The median. So what is the median of group A? Mina?
About 45.
Wait, 45? Yeah.
Well, it's in between 45 and 50, so we'll say 47.5. And group B, John?
Would be 40.
Okay, group B, the median is 40. So when we compare those centers, the group B is showing us that the median is less than group A at 40, where group A is 47.5. So that means that shopping time, the median point here is greater. Group A spends more time, okay, as far as the center goes. Now what about the spread? We can look at two different spreads, okay? We have the entire spread where we look at the whiskers. Remember we call these whiskers. So if you look at the spread, Majad, what do you see in comparison here?
It's almost similar to the.
It's almost similar. And then what about even the interquartile range? What do we see in the difference there as we compare them? Chloe? Okay, so it's a little bit bigger because it extends. Their beginning is about the same, but the group B goes a little bit bigger. Okay? So, as we reflect, question number 2, which group has the greater variability in the bottom 50% of shopping times? So variability refers to like the spread. So if we're looking at the bottom half, which group has greater range? Raise your hands, please. Jose? Group A. So see, there's greater variability here in Group A from the median to the lower quartile than there is in Group B. This is a more clustered, not as wide a spread. So that is, for number 2, greater distance to the minimum. But then Group B has a greater spread for the maximum. Okay? You see that? The top 50% is a greater spread because the median is less. All right, your turn. Let's look at this. Number 3. Go ahead. We are looking at the weights of football players in pounds. So compare the shape, center, and spread. You're going to have to wait. Okay. So let's take about 3 minutes and look at the shape. You're going to look at the center, the medians, and then the spread. Football players' weights, okay? So again, we're looking at the same items. Okay? All right, so we're going to do this together. Sebastian, you guys? All right, compare the shapes of these 2 box plots. We've got Group A and Group B again. So we want to look at overall similarity. These are little hints, things that you can look at when you're comparing the shapes. Overall similarity, box and whisker differences, if any. All right, so what do we see here in the overall shape, if we're comparing the shape of these? Who sees some similarities? Jose? Well, yeah, it's part of it's just learning how to express those similarities. Yes, Darwin.
Well, they both have a box plot.
Okay, they both have a box plot because this is a group of data that's been set up into a box plot so that we can look at the differences. They're on the same number line.
Yep.
All right, so overall similarity. Let's look at the box differences or similarities. What about the boxes? How different are they?
They're very different.
What do you think?
A is like a little bit wide. Well, yeah, a little bit wider,
Okay.
longer than B.
So what do we call that box? What range is that?
Spread.
Okay, it's the spread. But what's that big word? Starts with an I. Interquartile. Yes, the interquartile range is wider here than Group B. What about the whiskers? What do we see in the whiskers? Are they similar?
No.
Okay, so there's some differences. Which one is shorter or which one is longer?
I was just talking.
All right, Group A is longer. So that represents the least and the greatest points. All right, what about the centers? What about the centers? What do we call the center?
Median.
Median. So what about the median? Are they similar or different?
Different.
So they're different. Okay, let's just identify. What is the median of Group A?
249 or 248.
Well, actually, let's see here. This is 240, this is 260, so this is 250.
Oh yeah, I mean.
So 268. 267.
All right, so we're into 258.
Not 8.
Yeah, 258 for Group A. And what about, so this is 270 here. What's our
So 271 or 2.
271 or 2? So if you look at 258 to 271, so there is some difference there. And which one is greater?
B.
Group B. So it's always good, you can say Group B has a higher median at 271. And then what about the overall spread? We talked about the interquartile rate, which is the middle, 50%, but what about the overall spread? Jose?
Group A has a longer spread.
Group A has a longer spread from, all the way from 170 up to almost 335. Okay, so that is greater. Okay, so that's our example there. Okay, another example. Let's look at one that has bigger differences, so we can actually tell more. Now this is looking at. Listen up.
I'm listening.
Okay, then thank you.
Hit me.
This is a store that is selling wristbands. Okay, so we have store A and store B. So now this gets exciting. We have some differences in the information. So what can we tell about the shape? Overall, boxes, and whiskers. So let's look at overall. What do you notice? The difference between store A and store B.
Store A is
Raise your
more
hand.
spread.
Mary?
Store A is more spread than store B.
All right, store A is definitely spread out more than store B. What about the boxes? Like the length of the boxes, what do you see? For length of the boxes?
Well,
Bowen?
A is longer,
All right.
and it's more on like the between like I'm talking about the box.
Okay.
It's between about 31 or 2 and 55.
55.
And then B is more to the right, like between about 48 to 65.
Okay, right, to 65. So it's interesting. Let's look at the centers. All right, now this is something you can notice, and this shows a big difference. Look at the medians, and look at the medians in relation to other points. Okay, the median of store A is about equal to what part of store B?
The lower quartile.
Well, the lower quartile, the
Upper.
the least, you're right. See, the median of store A, do you see this? The median of store A is actually about even with the least value of store B. So that's definitely something to notice and point out. Chloe, you have an observation?
So like store A has a larger quartile range, but a smaller overall value.
Right. See, we're going to be able to tell who's actually selling more wristbands. Okay, so when we look at the center, see the median is telling us, like in store B, that half of the data is greater here, whereas half here is lower and half is greater. So, and if half of store B's value is less, that's still greater than store A. And then looking at the overall spread, again, store A has a greater spread, but because of this point right here, I want you to really emphasize that the low point of store B is quite a bit higher. So we know that there's a lot of days, we're talking days here, a lot of days where store B sold more wristbands than store A. So, think about this. What does this tell you about which store sold the most wristbands? Who has a thought? So store B, we can tell from this data box plot that store B sold the most wristbands. Okay? And let's look at, when you're looking at something like this too, you want to, you can pinpoint these, and you see that the low point is greater, the lower quartile is greater, the median is greater, and the upper quartile is greater. So 4 of those key points are greater than store A. So that really does tell us store B sold more wristbands. Okay, as we look at those points. All right, go ahead. All right, and so now actually we're gonna compare a third store selling wristbands. And we're gonna compare this store C to store A and B. And if you go to the next slide, I have them all together, because you kind of need to look at them all together. Let's see what this looks like. Go ahead. Okay, so let's look at comparing store C to B and A. First of all, let's look at store C in general. From 25 to 75 is the range. And then we can look at store C in comparison to store A. How different is it, or how similar is it to store A? If we look at store C. Again, we're looking at these key value points. So the low end, Jose, what do you think?
Store A and store C have the same least value.
Okay, they are. They're right about the same on the least value. What about the median?
Approximately same, because A is 43 and then C is 44.
Pretty
Yeah.
close, yeah, 44, 45, just a little bit higher, okay? And then we can look at like the greatest value in store C versus store A. And store A is a little bit higher, but those are very similar. The medians are about the same. The box is a little higher in general, so we could make an inference or make a guess, an estimation. Store C probably sells a little bit more than store A because some of the value, those key value points are a little bit higher. What about store C to store B? Are there any similarities or differences that you see here? Again, looking at these key value points. So the least point, is that about the same, Chloe?
Talk about
No.
The greatest point is
Right, okay, so the greatest point is about the same, and that's definitely something to notice. What about the median that shows us half the value?
it's store C's median is less than store B.
Right,
You don't like
so,
Arab people?
so half of store C's values are less, and the median itself is less. Okay, so if you were going to take a guess, again, we're inferring or predicting what information we can tell from this data comparison which store sells the most wristbands. You have a guess? Chloe? Store B. I would say store B. We could still say is selling more wristbands per day.
Go get it.
All right, questions on that? All right, we're going to go through our yellow whistle questions together. Go ahead. Our personal trainer, what we would have are 2 questions. Okay, so looking at all of these, excuse me, please.
They're arguing with each other.
Which of the following information can you use to compare 2 box plots? So we have 8 terms here. What about A, maximum value? Can that help us compare 2 box plots? No. Mina, thumbs up. All right. Range.
Yes.
All right. Is that a thumbs up? I think so. Range. We can use range to compare them. Minimum value.
Yeah.
I like that idea. Thumbs up. Interquartile range. Does that tell us anything when we compare?
Nah.
What do we think? How many say no?
Me.
How many say yes?
Not me.
Yes. Okay. I think the yeses win on that one. Interquartile range definitely tells us that's the middle 50% of our value numbers. And what about individual data values for a box plot? Can we tell that? Georgie's? No. See, that's what's different between the box plot and the dot plot. We don't have every single value. in a box plot. All right, so that doesn't help us in this case. What about mode? We haven't really talked about mode in a while.
Oh, I know what mode is.
Okay.
Mode.
It's the number that is repeated the most.
Right, so does that help us in a box plot?
No.
No, we
No.
don't even know what the mode is because we don't know
How
each
many,
individual value. Right,
That one.
yes, but that's a good point. And median, can we use that? Yes. And what about mean?
Yes.
Well, in a box plot,
Well, no, because you don't know all the numbers.
right, we don't have all the numbers, so we don't have the mean or the average. Okay, go ahead. All right, so now, and this, I want you to get out on your paper that you did your warm up or even on the side here. I want you to sketch this scenario.
What?
Two box plots have the same median, and you can make up your number line here, and equally long whiskers. If one box plot has a longer box than the other box plot, what does this tell you about the difference between the data sets? So I want you to sketch this scenario, okay? And you're going to turn this in with your warm-up.
Okay.
So sketch the scenario. Two box plots have the same median, but one has a longer box. So you know a box plot has 5 key points. And you're creating a sample box plot. And I want to know true or false for each of these. The box plot with the shorter box has more variability in the middle, or
All of them.
does the longer box? That's just a longer box. Those are both the same. The box plot with the longer box have more variability in the middle. 50% of the values, okay?
May I go to the street?
Okay, come this way, please. Okay?
Oh, that.
Yes. Okay. Does somebody have their box? Let me know when you have your box drawn. Okay? Okay. So if we look at, see if you can just see up here. If you look at the whiskers are at the same endpoints, but the boxes, one is longer than the other. So if we look at variability, which is essentially the spread between upper and lower quartile, which one has a greater spread or greater variability? A, the top one. There's more data in this box, or in this range. This is more clustered. This is greater. This is spread out more. So the variability is greater. Thank you very much.
والله طلعت روحي.
Okay, go up. Okay, that's fine. You do have a homework assignment on your Google Classroom. We have 10 minutes. Let's go ahead and get that started. I will come around and collect your papers. Thank you.